Okay, great. So I'm Emily. If you remember me from yesterday, I spoke about the Unix shell and about data handling on Holland Computing Center. This is going to be our last talk of our HCC Kickstart. We're switching gears a little bit here. I'm going to talk about the Open Science Grid, or OSG for short. This is a different, separate computing resource. It is separate but connected to HCC that you have access to if you need it through your affiliation with the University of Nebraska. So I'm going to talk about what it is and how to figure out whether or not it would be helpful for you to have access to. So I'll talk about what is OSG, what is it, what's sort of the the fabric of the Open Science Grid, who uses OSG. I'll talk a little bit about owned versus opportunistic use, which you don't really need to know too much about, but it can be helpful to understand sort of how it works. The characteristics of OSG-friendly jobs. So how, and finally, how would you determine whether OSG is right for you? What if it's useful for you in your research or not? And how to get started. So the Open Science Grid is essentially a framework for large-scale distributed resource sharing, so computing resources. As you can see on this map, the sites that contribute computing resources to Open Science Grid are distributed all across the continent, really. These are universities and national labs all over the country that contribute both, computing, storage resources, personnel, software, and all of the things that go into the fabric of the Open Science Grid. It is so, but what it is a large network of interconnected clusters that you can have access to. So you would submit your jobs to run on the Open Science Grid, and then your jobs would be sent out to run on. If you don't specify where you want your jobs to run, they could run almost anywhere that there's resources available for them at any one of these sites. So what it's meant to look like to the user is just one large resource that you don't have to worry about having your jobs, submitting your jobs to a bunch of different clusters all over the United States, because the software does that for you. The scheduler does that for you. You just submit your jobs at a gateway to the OSG, and then they go out and run somewhere, and your output files from those jobs are sent back to wherever you submitted them from, whatever the login node you submitted them from. So there's over 50 different research communities that are part of the Open Science Grid, and over 130 different sites. And through the OSG, over 100,000 cores are accessible to researchers. This plot just shows kind of how much computing is done on the OSG in a typical day. This is just from, I think, yesterday. So I don't know if it was a typical day or not, honestly, but over the last year, over 2.5 billion CPU hours were done on OSG. So it's a pretty impressive resource. So who uses OSG? OSG came from the high energy physics community, and they comprise the majority of OSG usage. But really anyone who has a job, computing job, and who is affiliated with some sort of nonprofit US-based institution can have access to Open Science Grid. So that includes us, of course. And any field of science where there's computing to be done, and the types of jobs that can run on OSG is essentially uses OSG. So there's a lot of different areas, even including some areas in the humanities that use Open Science Grid. Okay, this plot shows, I want to talk briefly about owned versus opportunistic use. So this shows the opportunistic core hours by virtual organization over the past year. So a virtual organization is, or a VO is just a virtual organization. It's just just an organization, a research group, essentially. So you may have heard of the high energy physics, THEO's CMS and Atlas. Those are the primary users of OSG. If you submit jobs through Crane, for example, through our portal to the OSG, then your jobs will be part of the HCC VO, or the HCC virtual organization. Most of the use of OSG is on dedicated resources. So these are resource, computing done by the owners of that computing resource. But when cycles are not being used, computing cycles or nodes are not being used, those or the cores on those nodes that aren't being used are contributed and donated to opportunistic use. So that's someone submits a job from a portal to the OSG, and that job is matched to a resource that's just idle, that's not being used at that time. So this is what's known as opportunistic use. You're using a resource that's owned and operated by a different institution. And this number varies quite a bit year to year, but about, I think one of the years that I looked it up, it was about 15% of the OSG usage was opportunistic. And in the past year, 545 million opportunistic core hours were done on OSG. Okay, so what type of environment is OSG? Rather than being a high performance computing environment, which is what Swan and Crane are, high performance computing environments, OSG is more of a high throughput computing environment, in that it's really ideal for workflows that are comprised of a large number of small jobs. So if you can imagine, you have hundreds or even thousands or even tens of thousands of small jobs that can run on a single core that you have lined up and are constantly putting pressure on the job queue, then you can get a lot done on Open Science Grid, where it might not necessarily matter whether one of your jobs fails or is killed, because it can just be restarted and put back into the queue, and you've constantly got jobs in the queue, and they're constantly moving through and sending back the output. That's a high throughput sort of environment. On the other hand, if you've got a job that requires 20, 100, 1,000 cores to run together in an MPI sort of environment, and you need high performance over a relatively short period of time, then that would be more of a high performance computing job. So you'd want to run that sort of job on your local resource, Crane or Swan. So not only is it a high throughput computing environment, but it's also distributed, which means geographically distributed all over the United States. There's no shared file system, so you're not going to just be able to randomly grab a file that you have stored in your home directory. You have to ship or transfer your input files with the job and software packages that it needs. And then the output files that the job creates are sent back. So you can't, you can't really interact with your job. These are jobs that run in batch mode. And you need to be able to ship your input and output files back and forth. And then I also talked already about opportunistic use. So because you're running opportunistically, your applications, especially if they're very long ones, can be preempted. So they can be killed by the resource owner's jobs that have a higher priority on that machine. So in order to avoid that, your application should, or your jobs should be relatively short and support being restarted. So if a job fails, you just put it back in the queue and restart it. Generally speaking, this doesn't happen very often. I would say, like, if your job runs longer than 12 hours or so you want to keep them ideally less than that. So just to reiterate some of the stuff I already talked about in a couple new items, the runtime of an ideal OSG job should be 1 to 12 hours. it should be able to run on a single core or just a small number of cores, because you're not going to be able to find 100 cores to run together on OSG. You will almost certainly have 100 jobs running at once if you have a lot of jobs in the queue, but they will be separate jobs. They will not be able to communicate with one another. Also, jobs ideally should be require not too much memory. You can request more memory than that, but you'll just find that the more resources you request, including memory, the fewer cores will match to your job. So you just won't have as many jobs running at once. They'll tend to stay longer in the queue and not take longer to match up to a resource if you require lots of memory or lots of cores, or more than one core. Ideally, your job would use statically compiled executables that you transfer with your jobs, non-proprietary software only, and your job needs to be able to run, in a Linux-based operating system in batch mode, so no interactive jobs, with graphical user interfaces that you need to interact with. These are not completely hard limits, so there's some exceptions to this. So if you have long jobs, you can implement checkpointing sometimes. This sometimes works and sometimes doesn't. There's some built-in checkpointing that you can use on OSG for some applications, or you can just write your own checkpointing into your workflow. This just means that your job image is periodically saved so that if it does get killed because it runs too long, it can be restarted where it left off instead of starting from scratch. There's also some limited support for larger memory jobs. Like I mentioned, you can request more memory, but your jobs will probably wait longer in the queue if you do. Up to a limit, of course, if you request too much, they'll probably never start. There are some partitionable slots for parallel applications using up to about 8 cores, but more than that's probably not going to be a good fit for OSG. And then there is some software, pre-installed software available so that you won't have to necessarily ship all of your a complete copy of R, for example, with your job. We do have some software that you can use on OSG. And there's support for Docker and Singularity. So if you have a Docker image that can run your job, you can also submit that to OSG. And the exception to the non-proprietary software rule is that you can run compiled MATLAB executables. So if you can't just run a MATLAB .m file like a script, but you can, if it's compiled, you can run it on Open Science Grid. Okay, so how do you determine, with all that information I just gave, how do you go about determining whether OSG is right for you? Well, the first question you have to ask yourself is, are your jobs OSG friendly? So you'd look at that previous slide that I had and decide if you think that you can make them fit a good fit for OSG. Even if they're not currently a good fit, could you break your job up into smaller pieces or whatever you would need to do to make it OSG friendly? If the answer to that is no, there's just no way to do that, then you can certainly continue submitting to HCC clusters. You don't need to use OSG. If you think the answer to that is yes, and you could make them OSG friendly, the second question you would have to ask yourself is, do you even need more computing resources? I mean, maybe you only run one job a week or something, and it's small, and you don't need access to more. And the extra work involved in getting your job ready to run on OSG and creating a new submit script for it isn't really worth the trouble, because you're not running out of resources. So if you don't need access to more computing resources and it's the overhead of getting it ready to run on OSG is too much, then the answer to that is no, and you can just, of course, continue to submit to HCC clusters. But if the answer to that question is yes, and you do need more resources, then you should definitely consider submitting your jobs to OSG and contact us for help with that. We have some documentation on it, but I think you can start there and then just let us know if you have questions, which you probably will. I think our documentation is not extremely thorough. So you'll probably want to just check with one of us and get a little bit of help in creating your submit script. So OSG uses the HT Condor scheduler rather than Slurm. So you'll have a different format for your submit script, and you'll need to specify certain things like your input files and your output files and stuff like that. So let us know if you need help, if you'd like to try that, and if you need help. And then here's finally, this is my last slide. So this is actually kind of a short little intro. For more information on OSG, that's the link to their website. And then the documentation that we have on it is linked in that second link there. It's just, you can search pretty easily by going to our main docs page and just typing OSG, you'll find that link. So thank you. Are there any questions?